All right, we're going to do lesson 7 and 8. So that's what you'll be doing on Zearn. You'll need a couple of pages. You need this one. It's front and back. I'm going to talk about this one for just a minute, and then you're going to pause the video and do it and correct it as a class. And then the back side, you're not going to do until the very end. And then we'll work on this together. All right, so have those out. This one is just a review, just to help see what you remember. It's decomposing fractions. That means taking them apart. All right, so any fraction I can take apart. I'm gonna pick a fraction you don't have on here. I'll do this one. 4/6. I can take that apart lots of different ways. All I'm doing is showing what kind of addition sentences can I make for that. So I could do 1/6 plus 1/6. How many 1/6 am I going to have? 4 plus 1/6 plus 1/6. For some reason, this is not the best marker. All right, but I can add it like this. I could also add it. I could say, hey, there's 2 of them there. I could do 2/6 plus 2/6, right? Because there's 2/6 here and 2/6 here. I could do 3/6. If I put 3/6, how many more would I have to add to get 4/6? This is really not a good marker. 3/6, 1, 2, 3, would be 1 left, plus 1/6. Another way I can do it is by multiplying. I could say, hey, 1/6 plus 1/6 plus 1/6 plus 1/6. Well, that's the same as saying 4 times 1/6. Okay? So I can decompose it multiple ways. And what I want you to see about these ones, when you add fractions, which part of the fraction stayed the same? I know I erased the other ones, but remember I had 2/6 plus 2/6, 3/6 plus 1/6. I could have switched that around. 1/6 plus 2/6. The denominator stays the same. So when I add or subtract fractions, I keep that denominator the same. Okay? So I want you to notice that. When you multiply, we do something different. I'm going to show you that in a little bit. We're not necessarily going to multiply lots of fractions, but we are going to do something in order to make equivalent fractions. All right, so I want you to pause. I want you to take a minute and do this and then correct it together just to see where you're at, to give you a good refresher of what we've already done. When you come back to the video, you're going to start with this side, lesson 7, problem set. All right, I hope you did well on that. We're going to try and go pretty quickly through these. So if you need to pause it and slow down, then you're going to do that. If you need extra practice, you'll do it on Zearn. But also I want you to see that what we're going to do with this, we're also going to do tomorrow, but it's just going to be opposite. So I'm going to show you something already with it that we're going to work more on tomorrow. So you'll see there's kind of 2 parts to this. And if the second part is a little too confusing, then you'll pick it up tomorrow. All right, so I want you to grab this. Remember that we worked on equivalent fractions. Okay, so if you look at these, if you were not looking at any of the extra lines they put in on any of these, if you kind of look at it from back here on mine, where you can't see up close all those other little lines, how many does each box have? It each has 2. Right? So is that my numerator or denominator? That's my denominator. So what I want you to do, even though they did that first one for you, we're going to do something with it. I want you to write underneath the fraction. They're all going to have the denominator of 2. How many are shaded in each box? 1. So it's 1 out of 2. Okay? I want you to notice how large I wrote that. There's still room underneath. So on each one, write 1/2. 1 out of 2. Okay, now remember we used these and we made equivalent fractions, so fractions that are equal. So what they did right here, they put, I know you have these kind of little white lines, those mean nothing, so don't worry about those, but they put this one dotted line in there. They split it up. So now how many pieces do I have? 4. So you're going to write that, leave a little space in between. Don't even write the equal sign or anything yet. Put it over this way, okay? And when I have that line in between, how many are shaded? 2. So 1/2 equals 2/4. All right, now they wrote it up here for you. And I'm going to show you exactly what we did. But they did something that's redundant. Say redundant. Redundant means over again. Okay? To say it over again or to do the same thing over again. So I think it is redundant to write this down again. They said 1/2 equals 1/2 times 2 equals 2/4. Well, I don't need to write 1/2 twice. Remember, we're lazy mathematicians. That means we get to the correct answer our fastest way possible. It's not fast for me to rewrite it, so I don't rewrite it. What I do is I say, what did they do here? What did they multiply in order to go from 2 to 4? Okay, well, I can see they put one line in here. They separated it. So now they have 2 boxes. They multiplied it by 2. Okay, so what I want you to see is when I'm looking at these, this is an easier one. We know this one. But as you get into harder ones, what times 2 equals 4? 2 times 2 equals 4. So just put times 2 over 2. So it looks like this. What we're really going to work on tomorrow, but I'm going to have you practice a little bit today, is one of the other ways I could do it is say 4 divided by 2 equaled 2. That's what they multiplied by. Okay, so what I'm doing is I'm saying, hey, they had 1/2. They split it in 2. That means they multiplied it by 2. Now, when I multiply it, it's different than addition. I have to multiply both the numerator and the denominator. If I'm making equivalent fractions, it has to be by the same number. So 1 times 2 equals 2. 2 times 2 equals 4. Okay? All right, so we're going to do these other ones. I'm going to show you. We'll work through those, but I want you to see something. I can take any fraction and I can multiply it by n or x or y or z, any of those numbers, okay? We're using n to say any number. I can multiply it by any number and make an equivalent fraction as long as I multiply the numerator and the denominator by the same number. So take 1/2 and let's multiply it by 8. So we're going to do 8 over 8. So if I had an area model, really, these are called area models, but as you're going to see when we do these other ones, they're almost like arrays. You know that arrays look like this. They have the dots. Can you see my array there? So this is an area model. This is an array, but you're going to see it's almost the same thing. It's just counting by, okay? So now do this really quickly. 1 times 8 equals 8. 2 times 8 equals 16. What are my 2 equivalent fractions? 1/2 equals 8/16. All right, so we're going to do these ones and we're going to go pretty quick on them. All right, so what I want you to do is I want you to pause the video. I want you to see what's their equivalent fraction and write it over to the side. Leave the middle empty on all 4 of them. So now that they have the lines in there, how many total boxes are there? That's your denominator. How many shaded boxes? That's your numerator. So pause and do that very quickly. All right, you should have those. Now, what I want you to see is you're going to check the answer with the area model, but look at these. Look at the denominators. 2 got to 6. We know we multiplied. 2 times what equals 6? Or 6 divided by 2 equals what? 3. So they must have multiplied by 3. Check your area model. Did they break it into 3 groups? 1, 2, 3. Well, then they multiplied by 3. 1 times 3 equals 3. 2 times 3 equals 6. That's an equivalent fraction. 1/2 equals 3/6. Okay? Let's do this one together, and then I want you to do the last one on your own. I can look at either. I've been showing you the denominator, but if my numerator is 1, that might be the very easiest. What do you multiply 1 by to get to 4? 4. 2 times 4, does that equal 8? Go backwards. 8 divided by 4, does that equal 2? Or 8 divided by 2, does that equal 4? Exactly. So multiply it by 4 over 4, and you get equivalent fraction. 1/2 equals 4/8. Now I can, I said make an equivalent fraction for 1/2, I can multiply by anything I want, as long as I use the same number in the numerator and denominator, and that'll make an equivalent fraction. I want you to do this last one very quickly by yourself, and then check with the video to see if you got it right. All right, did you say you multiplied by 5? 1 times 5 is 5. 2 times 5 is 10. Looking backwards, that's a 5. I was like, 5 times 5? That's the wrong answer, but we had it right. I was just reading it backwards. 2 times 5 is 10. Okay, we're going to use a total different fraction, and we're not going to draw an area model for it. I want you to write the fraction 2/3. Right there. Oops, don't write equals. I don't know why I did that. 2/3. I want you to multiply it by anything, as long as you multiply the numerator and denominator by the same number. Make an equivalent fraction. Check back and see mine, but yours may be different than mine because it depends on what you multiply it by. All right, whatever you multiplied by should look like this, but it might not be 4s. As long as the numerator and denominator are the same, you made a fraction that equaled 2/3. Mine is 2/3 equals 8/12. Check with the people around you and see what you multiplied by, what they multiplied by, and see their equivalent fraction, and then flip your page over. All right, did you see all the different equivalent fractions? All right, we're going to do pretty much the same thing on this side. The other side wanted you to take it a little bit slower, but we're so smart, we just kept moving. All right, so we're doing the same thing here. You're looking at it saying, what's the first fraction that they had? So you have to think, it can get a little tricky because you're trying to count and figure out with these lines here, and you have to pretend that those lines are not there. So if I was looking just at the full bar all the way down, it would be, oops, I was looking at this one. They already did this one, so let's just look at this one. 1, 2, 3. Do you see those? That's where they got their denominator of 3. And then how many are shaded? 1, 2. So 2/3, and they cut it in half. So now they multiplied it by 2. Instead of 1 box, they have 2 boxes, right? Or 2 lines of them. Okay, it's like an array. So now, how many total boxes do they have? 1, 2, 3, 4, 5, 6. That's my new denominator. And how many are shaded? 1, 2, 3, 4. That's the new numerator. But what did they do to get that? You can think, what times 2 is 4, or 4 divided by 2 is 2. They multiplied the numerator and denominator by 2. Okay, so we're going to take it in a couple different steps. First thing I want you to do is write down the first fraction that they had for each one. Okay, and then check with mine just real fast before we write the next one. Remember that you're just counting all the way down. Like this is not 1, 2, 3. This is 1, 2. Okay, count them like that and write the first fraction that they have, and then check back very quickly. All right, check yours with mine. This one is 3/4. This one is 4/5, and this one is 5/6. Okay, now I want you to pause it and see and write down over on this other side, leave some space in the middle. Write down what is their new fraction after they made these other lines. So now these were 1 big block, right? I had 4 big blocks, and now they've made it where each block is multiplied by something, and there's 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's your denominator, and see how many are shaded. So pause and write the equivalent fraction. Just leave that space in the middle, and then check back with mine quickly. All right, let's look at our new fractions. Now when they broke these up, okay? This one is 9/12, 8/10, and 10/12. All right, so what we're doing is we're saying, hey, these are equivalent fractions, but we want to know what did they do to figure that out. Okay, so what you're going to do, you're going to do it on your own, and then you're going to check back with me. You're going to look at it a couple different ways. Okay, I always do the denominators. I'm not really sure why. I guess you could do the same thing in the numerator, but I always do the denominators. So check and see right here. 4 and 12. Think of how are they related? What times 4 equals 12? Or 12 divided by 4 equals what? That should be the exact same answer. Okay, we'll do this one out loud together, and then you can do those bottom ones. So 4 times what equals 12? 12 divided by 4 equals what? You should have said 3 for both answers. 4 times 3 equals 12, or 12 divided by 4 equals 3. If I'm going to multiply it on the bottom, I need to multiply it on the top. So it's done for me. 3 times 3 is 9. 4 times 3 is 12. Very good. Do those bottom two and then check back with the video quickly. Okay, what did you say? 10 divided by 5 is 2, or 5 times 2 is 10. So you should have multiplied this one by 2 over 2. What about over here? 6 times 2 is 12, or 12 divided by 6 is 2. We multiplied them by 2. Okay, 2 over 2. Before I told you that this looks to me a lot like an array. We call this the area model, but this looks like an array. Look, I have 1, 2, 3, 4 across the top. And 1, 2, 3 going down, counted by 4s. 4, 8, 12, right there, right? So you can, I don't want you to get confused by the area model, because it really is just like drawing an array, okay? Except that arrays use dots. Same thing, okay? All right, now we're gonna look at the bottom. This one tells you decompose the shaded fractions into smaller units as given below. Express the equivalent fractions in a number sentence using multiplication. We're actually going to do that first, and then we'll double check it with the area model, because you're not always going to use this area model. In fact, until I taught this in 4th grade, I've never used an area model. This is just so you can see it. But once you see it enough in your brain, you don't need to draw these out. Okay, that's why I want to start with writing the number sentence. So figure out what we have right here. 1, 2, 3, 4, 5. Is 5 my numerator or denominator? Denominator, write that down. And how many are shaded? 3. That's my numerator. Okay, now it says decompose into tenths. When it's telling you that, it's saying break it down so that you have 10 different units, okay? So that 10 is my denominator. Write that down. Okay, now take a look at it. 5 times what equals 10? 10 divided by 5 equals what? 2. So we're multiplying by 2. 2 over 2. 5 times 2 equals 10, which means 3 times 2 equals 6. That's my missing numerator right there. Okay, now go back and draw it. If these were 5, how many do I have to break them down into to get to 10? 2 groups. Draw a line. Okay, we know 2, 4, 6, 8, 10. There's my denominator. Count the shaded ones. 2, 4, 6. Did I get it right? We did it. Very good. All right. So let's set this one up, and then I want you to try it on your own. This is broken up into what? 1, 2, 3, 4, 5. Numerator or denominator? Denominator. All right. How many are shaded? 3. What do they want my new denominator to be? They want me to break it down into 15. Okay. Pause the video and see if you can figure out what did they multiply by, and figure out what my missing numerator is. Did you do it? 5 times 3 is 15. Or I could have said 15 divided by 5 was 3. So I have to multiply by 3 over 3. So now 3 times 3 equals 9. You got it. Very good. All right. So I want you to take that paper home with you. And I want you to work on this one. So I'm going to go through it with you, and then you're going to work on your own. Make sure you're asking questions if you have them, and practice it on Zearn also, okay? Zearn's going to go through it a little bit slower. Tomorrow we're going to practice again, but we're going to work with mostly just the division part of it, which is just the opposite of multiplication. So you're doing the same exact thing, you're just doing it backwards, right? It's like saying 2 plus 3 is 5. 5 minus 3 is 2. We're just working it backwards. That's all. All right. So look right here. Part 3. It says draw area models to prove that the following number sentences are true. Now you can draw it. That's totally up to you. If you want to draw it, feel free. If it was me, I'm just going to figure out what they multiplied by. So I'm going to look at those denominators. 2 and 10. 2 times what is 10? Say it out loud. 10 divided by 2 is what? Say it out loud. Was it the same number? Should have been. So I'm going to write 2/5 times 2/2 equals 4/10. Because I said 5 times, oh, I said it backwards, didn't I? Because I looked at it backwards. I just realized that. I went to write it and I was like, did I say 5? Ah, goodness. I hope you figured that out. When you look backwards in the video, you can't see it. It's when you look at it yourself. This is a 5 backwards to me. So this looks like a 2 and this looks like a 5. Or sorry, this looks like a 5, this looks like a 2. They look backwards, sorry. So 5 times 2 is 10. 10 divided by 5 is 2. You said the same number, okay? But that's what you're figuring out, is what did they multiply by. If you're not sure yet, then you need to draw it out. I don't want to do both because I don't want to do the extra work. You're going to do both only if you need that. If I need to draw it out, then I have to draw 1, 2, 3, 4, 5. I have to draw that I have 5 of them and that 2 are shaded, right? And then I have to break it in half because I have to multiply it, right? So now I have 2, 4, 6, 8, 10, and how many are shaded? 4, okay? So you're going to do one or the other, whichever makes more sense to you, all right? Look at number 4. Use multiplication to find an equivalent fraction for each fraction below. So these ones might not all be the same answers as the people next to you, okay? So all you're doing is taking whatever fraction they have, multiply it by any number. 3/4 times, did we do that one already? No, we did 2/3. And 3/4 times whatever you want to do it by. I'm going to do it by 3s. 3/3. So 3 times 3 equals 9, and 4 times 3 equals 12. But you could put any number in there as long as it's the same on the top and the bottom, the numerator and denominator. So do those 4 like that. And then on the bottom it says determine which of the following are true number sentences. Correct those that are false by changing the right-hand side of the number sentence. And not just the right-hand side. Change it completely, okay? So what you're going to do is you're going to look at these and say 4/3 equals 8/9. 4/3 equals 8/9. 3 and 9, how do they relate? 3 times what is 9? 9 divided by 3 is what? She just said 3 both times. Okay, so what you have to look at then, did they multiply both by 3? 4 times 3, does that equal 8? Does 3 times 3 equal 9? Yep. But to fix it, I'm going to make it look like this. 4/3 times 3/3. 4 times 3 equals 12. 3 times 3 equals 9. That's the equivalent fraction. Okay? If it's correct, circle it. That way you'll know that you did it, and we'll know that you did it, and that you think that that's correct. All right, so do those, do your very best on them, and then do Zern, lessons 7 and 8.